Hi guys, and very welcome to this tutorial. This will be a third part of the introduction to Houdini Flip tutorial. I decided to do this tutorial because I forgot to cover the topic about the volume preservation. And as an extra, I will show you today how to create wet maps. We will be creating something like this. You see, you have your wetness, and with the decay, the wetness is disappearing. You can download this geometry from CG Trader. This is a free download. You have to register, and I provide you with a link. Let's move on to the first topic. As you see here on the left side, we're losing volume, on the right side not. The parameter responsible for that is the particle separation, but it's not the particle separation on the flip object that you already know. This is particle separation on the flip solver. I show you where you can find this parameter. If you go inside your setup and dive inside your dot network, under your flip solver, under particle motion, under separation, you have to activate this apply particle separation. What this parameter actually does, it try to keep this particle separation within the simulation. Okay, let's move on to the next topic. With the knowledge from the two previous parts, you'll be able to recreate this setup. If you didn't watch the previous parts, I will highly recommend to do this before you watch this one. I will fly through now and explain you how I create a source and how I source my flip here. And then we go to our topic and we'll create the wet map. First thing I did, I brought my geometry inside my FX container and I created the collision source. You already know how to do it from the first part. And then I just copy and paste this voxel size from the flip source. Then I use bound to get the container dimensions. And I isolate top with a group named underscore top. I activate or keep by normals. And I give a direction here. Everything what hits this direction will go to the group, and then I blast everything, or I blast everything what inside the group, and then I reverse the normals. I transform it a little bit smaller and down because I like to have my source inside this container, otherwise we'll not get the fluid. And then I created the flip source. I set my particle separation because you already know how to do this connection. I already explained it in the first part. And then I separate the particles from volume. As you already know, this is the flip is sum of the particle and volume. And then I created some noise pattern because I like to separate the white areas to get the rain out of these areas. Let's dive inside and look how I did it. I'm using here the same idea that I use for in the second part for creating noise pattern for initial state. Only different is that I don't use the 4-dimensional noises. I use here the 1-dimensional noises. For animating offset, I use the time multiplied by speed parameter. Then I separate the components and offset them. The Y component I offset by 0.5, the Z by 0.7. Then I gather them with float to vector node again and put in offset. Then I fit the values because, as you already know, the turbulent noise give us the values between minus 0.5 and 0.5. And then we use here the log frequency noise, and I offset its offset with multiplier 0.7. And I fit it again because this is also the turbulent noise. And then I multiply these two guys together. Let's see first what the result of the high frequency noise. And this is the result of the low frequency noise. They both are animated. And then I multiply them together and I get this result. The next step is blasting these black areas. I use the blast node with this expression. Actually what I'm saying, if the red value of the color of the points is less than this threshold, just blast them. Now we're left with this also animated. And the next step is to project these points on the geometry and emit from the places of the hit. Okay, let's see how we can do this. For this I use attribute warp. If you go inside, I use here intersect, and I just grab the position here, and if you look here carefully, this is the head geometry that I like to project on. This goes to the second input and my points going to the first one. And what I'm saying here, just take this point and just project on this geometry. By default, this intersect gives you here the ray direction with 0. That means how deep your point will look for the collision. You see, I just put it here, -20 is enough a distance to get the whole geometry. And if you look at the result here, we're getting this. You see, if you look on your simulation now, this is animated because we have animated area here, and we just arraying these points on a geometry. Okay. And then I just merge them together because I have here my source, my volume, and here I have my points, and now I have everything what I need for the simulation. You already know how to create the emission setup. I have my collision object here set to a volume sample, and I grab my VDB from here and geometry from here. What I did here, I like to replicate some kind of rainy behavior. If you look carefully here, what it does, this expression, it just turn on and turn off your activation. It just turn on, hold for a couple of frames, and turn it off again. First, I will show you on the simple example how it works, and then you can use it in your activation. Okay, imagine this 0 is off, 1 is on. I use first here the sine function, and I put frame inside and multiply it by the frequency slider. What it gives me now, if you play, it goes now from -1 to 1. Then what I'm doing here, I'm offset this all value by 1, because I like to have from 0 to something. Now it's from minus to 1. I offset it by 1. Let's see the result. And you see now it jumps from 0 to 2. Then I clamp the values from 0 to 1. Let's see the result. Now it jumps, wait a little bit, jumps back, wait a little bit, you see here. And what I do here, I just create the integer because I don't want to have any in-betweens here. Let's see the result. And now you have this behavior. It's on for a couple frames, then it's off for a couple frames on. Okay, let's get inside the top network and use this idea inside our volume source. if you look inside the activation, it's the same thing, but in one line. You can write it in one line. You see we have first our sinus function with a frequency. I created a slider for this. And then I use clamp. And I don't use an integer because the activation is here already integer, is clamping automatically this to integer values. How to create this parameter you already know. You go here, edit parameter interface, and create your integer parameter. You see I have it already here. As is float, doesn't matter. Okay, great. Now if you look at your setup here, it's just doing the same thing. 1 for a couple frames, turn off for a couple frames. That gives you some noisy pattern. Okay, great. What I did then, I just import my simulation. You already know how to do this. We use DOP import field, just put our DOP network inside this one, and just select our flip object and choose the preset. For flip, you have to have the 3 guys. And then what I did here, I just blast the droplets. As you see, if I have any droplet here, I think I don't, but if you have, yeah, it will. You see you have here your threshold and you can blast them, but it's doing nothing because I don't have a droplets here because everything is like one mesh. Okay, then what I did here, I just compressed this cache with compress node here, and I did it for 48 frames. Okay, on the compress fluid, you have to also copy and paste your particle separation to be able to get your resolution for the compressed cache. Then what I do here, I unpack my points because I like to have points, and then I give these points white color, no black color, sorry, because I like to have black wet map. On the other side, I import the head again with an object merge. I bump a resolution a little bit higher. You see I use here open subdiv bilinear with subdivide node and depth set to 3 to get more resolution for our wet map. And then I use here on this side color white, and I use attribute transfer and transfer this black color of these points on this collision object. You have to, by default, is already take your color in consideration. Only thing you have to change the distance threshold, because by default is 10. And this is very big value here. And now you see what we have. If you play you get this. Have this rainy behavior. It's looking like wet map, but we have no decay. Let's see how we can create this decay. First, I like to explain how this whole setup works, and then we will build it from scratch. First thing we need is an accumulation of the black color. How can we achieve this? We have to compare the previous color of the frame with the current one and take a minimum. For example, in this case, now we have the current frame is white, previous is also white, the value is 1, the minimum will be 1. Once it hits here, the fluid hits the collider here, it becomes black. The current value is now 0, the previous was 1, the minimum of these two guys now becomes 0. Sometime, maybe in a couple frames, this area will become white again. But the previous frame is still black. The minimum of these two guys will be 0. This will stay black. Long story short, once this area becomes black, it stays black forever. Let's see how it works now. This is without accumulation. You see, just like we have white and black. When it hits, it's black. When it's left, it's white. With accumulation, just go back. You see now we have accumulation here. Okay, let's move on to decay. For calculating decay, we need two attributes. The first one will be integer activate, and the second one will be a decay time. The activate is 0. When the fluid hits the collider, it becomes 1. And since this time, when activate is 1, decay time will increase. And then what we have to do, we have to just multiplicate our decay time with some decay rate. In this case is 0.03. And this value will increase, and we just apply to our black color. What's happened, every frame, it will get brighter and brighter. And then we have to clamp it from a 0 to 1, because if we have, for example, 100 frame left, our value become here 3. But we need only the value between 0 and 1. That's why we have to clamp it from 0 to 1. Okay, let's see how the activation works. It's actually very simple. By default, we have activation 0, and we're just saying if the red component of the color becomes less than this threshold and activation is 0, when these both conditions are true, then makes the activate 1. It will be then when the first time the fluid hits the collider here. Let's see. We just activate this guy here and look at the spreadsheet. I already filter the activate. You see activate here is 0. And if you play, you see some of them becomes a 1 and stay 1. Okay, let's move on to the decay time. What we're doing here, we're just grabbing the previous decay time with a point vex function from a first input. You see here, we're just going here. And we're just saying if activate is greater than 0, the decay time is increasing, because we're taking the previous value and increasing this by 1. Let's see in the attribute spreadsheet. You see when it's become 1. Oh, sorry, I have to go outside of the solver because it doesn't show it right. We have to just make it with control. You can click here and just reset simulation. Just doing something here. Okay, just go back and we just resimulate. And you see now we have this. If active become 1, you see this time now is increasing. Okay, great. Let's build it from scratch. First, we need these two attributes. Let's create a wrangle and connect our attribute transfer to the first input here. And we just define these variables. E@activate is equal 0. And we have f@decay time. Decay time is equal to 0.2. Okay, now let's create a solver. connected attribute wrangle to the first input, dive inside. Our previous frame is here and our current frame is here. First, let's do the accumulation. What I do here, I create a wrangle and connect my current frame to the first input and the second or previous frame to the second input. Let's grab first our previous frame. I create a vector variable. I just say cd or color, and it will be point expression because I like to grab a color of the points from a first input. I like to grab a color. This is cd, and from which point from running point it will be integer at ptnum, and don't forget the semicolon. And now we compare these two, and we'll say the at cd is equal the minimum of the previous frame cd and a current frame cd. Okay, let's see how it works. Just go here, take this guy, and you see now we have this accumulation. Great. Let's move on to activation. Let's create another wrangle. I just connect it here because we don't need here the previous frame. And I say here, if our v at cd.r is less than a threshold, I create a slider. It will be a threshold. And our e at activate is zero or equal to 0, then set the activate, e at activate to 1, semicolon. Let's look how it works, or if it works. You see we have an activate here. Just run it. I have to maybe click again. And sometimes it doesn't work. Just look here. Activate. Ah, okay. My fault. I forgot to create a threshold. We just do here 0.1 or something. Let's go outside. Click with Control here and resimulate. And you see now we have the activate becomes a 1. This is working. Now let's move on to our decay time. Okay, we have to create a new wrangle. And this time we need our previous frame. That's why I connect the previous frame to the second input here. And we just grab our previous decay time. I will say float decay or previous decay time is equal. I use point expression again, and I grab from a first input the attribute named decay time, and from a running point at ptnum, don't forget the semicolon, and we will say if e at activate is greater than 0, then we'll like to increase our decay time. I will say f at decay time is equal the previous decay time plus 1. Okay, Let's see if it works. Let's go outside, click to clean a cache, and you see it is working. Now let's set up the decay rate. Let's create another wrangle. And now we'll see the add CD is plus equal this decay rate multiplied by decay time first. I would say channel F. We need some slider. It will be decay rate. And I like to multiply it by our decay time. It will be F at decay time. And as you already know, this will get brighter, but we like to clamp it between a 0 and 1. Because the clamp function, dex function, needs a value. This is our value, and the values to clamp. Our value will be this, and the minimum will be 0, and maximum will be 1. Okay. Let's see how it works. We just look at our color here. I just look at CD here, the CD, or we can just look at the result here. First, I like to create my decay rate. I just see 0.1. It will be a little bit slower now. You see now we have our color, and you see it slowly have a decay. In this case, it's very slow. That's why I put here 3. And now you'll see it will get brighter quicker. Okay, great. We will render our setup in the Karma XPU. First, we have to create a null. I already created, and we just connect it to our result here, to our wet map here. And now we just go out, create new geometry container. And I will say this is our final. Go inside and bring your head with object merge inside this container. Just take your render here, accept. Okay, now let's bring it into the stage. Just change it to stage and create a scene import here, because we like to create, bring a head inside the stage here, and we just go here, and under object we just get our final here, and you see now we have the head here. Now we need a camera, we need a light, and also we need a Karma render. Let's first create a light or camera. Just click with the control button on the camera. Let's take a little. Now just navigate to inside the camera, and now we just lock the camera. Now let's create the light. I just go and create environment light, and we just take the Houdini HDR. And now let's create the Karma render. Okay, and by default it's using CPU. Change to XPU. You have to be You have to have a graphic card to support this XPU renderer. And let's see, if you go here and just click on the Karma XPU, you will see the result here. Let's just rotate our light because now it's go to transform and rotate it maybe 90 degrees. Something like this will work. And maybe take exposure down a little bit. Maybe -1. Something like this will work. Okay, let's go and create the material library and material assignment. Okay, let's create the material library and also material assignment. Okay. Inside this library, we will create the XPU material, and with this node, we'll assign the material, created material, to this object. I will show you how to do it, but let's first create the material, the basic material. Just go inside here and just do generic shader, Karma, Karma X, USD material builder. Just click here. And now you can dive inside. You can just rename it to head. And now just dive inside. Now I like to put our textures inside here. And let's see how to do this. Let's bring our images and connect them to the correspondent inputs here. Let's go for image, and you have this image texture 2D. You have to be careful here because we will need a couple different signature here. First, we are working with a color here. We change our color space to ACES CG because by default the Houdini uses ACES, and we connect this out to our base color. And now let's grab the file. You already downloaded your textures. I have them here, and I take here this base color. And you see now we have our base color here. Let's bring the other ones. I just duplicate it with Alt because we need the roughness. The roughness in this case is the raw, and roughness is also float, is not a color. And let's bring the roughness here. I just go here and I say, where's the roughness? Roughness here, roughness PNG. And you go here from to specular, and you have here this specular roughness. You see is type float here. I duplicate it again. I just duplicate the color here. It will be also raw because we will use now the normal map. That will be this head normal OpenGL PNG. And we'll connect this to the geometry, to the normals. And the last thing we need here is displacement. I just take this one because the displacement also grayscale is also raw, and we just get this displacement. In case this is the height PNG, let's accept it. And we need we don't need anything. We just take this one and bring it to displacement. Now let's just see our result. Okay, now we created our material, but we didn't assign it. We go to assignment here, and to be able to see your content here underneath all your geometry that we brought inside the stage, we have to just change to Solaris here. Be careful, sometimes the Houdini crashes. That's why I just save my file before I do this. And I go now to Solaris. It will take a little. Now you see you have your setup here, and also you have, this was my old one, and you see you have your all materials, the cameras, your geometry here. You see the material here, your light, your camera, and also your polyhead that you brought inside a stage. What I like to do here, I just press D here and just go to background and just do dark here, display environment. I don't need this. And also what I like to do, I just click here. I don't want to see the cameras here, and also I don't want to see this light here. Just take the light away here, just take this grid away. Now you can navigate to your camera. We didn't rename this camera. And now if you look in your XPU renderer, you will get your results through the camera, but we didn't assign the material. Let's assign it first. You see an assignment, it needs the primitives and also your material path. But you can do this, you just click and drag your geometry to your geometry and also your material to the material. Now let's take a little bit to update the scene, and you see we have something, but the displacement is way too high. Let's adjust the displacement. Just go inside, go to displacement, and we just put it down to 0.1. Let's see now. Now we have our head here, but we don't have our wet map. Let's see how we can bring it in. First, I like to change the texture here to get a better result. Just go here and change it to this skylit garage and just bump up the exposure. Okay, great. Now let's go inside our material builder or material library and bring first our color. You can do this with geometry. This geometry color node. You can connect and watch the result. And now we can multiply our color with this geometry color with a multiply math node. Just connect the color to the first input and the geometry color to the second, and just connect it to the base here. And now you will see your wet map. Okay guys, that's it for this tutorial. Thank you very much for watching. If you like this tutorial, subscribe my channel, stay with me. This all files, according to these 3 parts, you'll be able to download from Patreon. Next week I will provide you with a link, and I'll see you in the next exciting tutorial. The next topic will be basics of 3D bodies. I'll see you there. Bye.